All right, today we're going to be looking at lesson 5.7, which is our area parallelograms, geometry 6. And hopefully this will be a pretty fast one because you should be working on this or have been working on this since 4th, 5th grade, finding your area of rectangles. But today we're going to expand that to all parallelograms. Now just a reminder of what area is. An area is the inside of a two-dimensional figure. Now we've talked about area before, and that is how many square units. If I had square units, how many of those squares would it take to fill in that entire area? So you have learned, I'm sure, a lot of you said like length times width when you were in elementary school. We're going to kind of call that the base and the height instead, how tall it is. So when you're finding the area, you would tell me, I'm going to go ahead and do the base times the height. And you would tell me 5 inches for the base. 3 inches is how tall that figure is. And you would have come up with 15 inches times inches are inches squared. Areas always are square units. Remember I just said, how many squares would it take to fill in? Now this one over here is also a parallelogram, but we have to be really careful because a lot of people would like to tell me it's 6 times 5. But this was a trick question. When you go to the doctor, do they say, okay, we're going to take your weight and your height. Now, I want to see how tall you are. Can you please lean against this wall right here? Is that the height? Of course not. That's not the height. Your height is, they always tell you to stand straight up. So you have to be very careful. If they just give you a regular parallelogram, you have to actually look to see how tall is that parallelogram from one end to the other, straight up and down till you get that 90-degree angle. They have to give you this measure here or you really couldn't figure that out. So let's just pretend this was 4 inches. If that's 4 inches, now I could actually find my area. My area would be the base times that height. But again, the height is not part of that parallelogram. The height is how tall is it from the top right here to the bottom right here. How tall is that? So we would say 6 centimeters times 4 centimeters. Oh, I put inches over there, didn't I? I better change that just so I don't confuse people. Centimeters, there we go. And now when we go ahead and multiply it, you would tell me it's 24 centimeters squared. Much different than what many people would say 6 times 5, which is 30. Again, that's why it is not. So we're just writing out the formula in words. Area of parallelograms, and remember, parallelograms aren't just this shape right here. This is definitely a parallelogram, but remember when we were doing our shapes, parallelograms are rhombi, if it's a rhombus, if it's a square, if it's a rectangle, or a parallelogram. They're all parallelograms. So when I'm looking for that formula, area is the product, which means I'm multiplying. And what am I multiplying? I'm multiplying the base, and I'm multiplying that to the height. That's where we're coming up with this formula that you see right here. Area is the base times the height. Any parallelogram, again, rhombi, square, rectangle, regular parallelogram, that's the formula I'm going to use. So 2 quick examples, and you're going to have some homework like this. 3 through 10 on that worksheet I'm going to give you is going to be like it. And I wrote down the steps. The very first thing I want you to do is I want you to go ahead and write out that formula, which I already did for you. But then step 2, changing the variables to the given values. So let's look at this shape. Which one is the base? Absolutely. Your 10 is your base. But did they give you the height in this picture? You're right, they didn't. So you really couldn't have done this at the moment unless you could have figured out what the height is. They'd really have to give you some kind of perpendicular distance from the top to the bottom for you to actually do this one. So we're going to say it again is 4 centimeters. Now you can figure it out. That would be my height. So let's change it. I don't know the area, so that has to stay capital A because we don't know it. But the base, you do know. It's 10 centimeters. The height, you do know from the picture. It's 4 centimeters. And then we're going to multiply those together to give me the area is 10 times 4 is 40. And centimeters times centimeters is my centimeters squared, or my square centimeters. You've got to be also very careful to remember to include those units. So what's my answer? 40 centimeters squared. Let's go ahead and look at this next one. For B, again, I already wrote out that formula for you, so you don't have to worry about that, but let's replace the variables. A, we don't know. We don't know the area, that's what we're trying to find out. Base, there it is, 1.5 feet. The height, they did give me that nice perpendicular distance from the top to the bottom, 8.1 feet. Now, some people would say, oh, this one's so much harder. It's not harder. Just because there's decimals doesn't mean you're doing anything different. So to find the final area, we're just going to multiply our 1.5 times our 8.1. Well, 5 times 1 is 5. 1 times 1 is 1. Put your placeholder and go to the next one. 8 times 5 is 40. Put down the 0, carry the 4. 8 times 1 is 8 plus 4 is 12. So we're going to add our partial products here. And notice I have 1 decimal in this problem. I've got 1 space the decimal here. So in my product, let's go over 2 places, put my decimal in, and I get 12.15. Feet times feet is our feet squared. So that's where I'm getting my answer of 12.15 square feet. So that, again, should be a review because it's very much like when you were finding just the regular area of a rectangle, but we're expanding it to include all of our parallelograms. If you have any questions, bring them to class with you because we will cover it. Otherwise, I will see you soon.